Assalamualaikum warahmatullahi wabarakatuh. I'd like to present the second paper for this third international conference on bioscience and biotechnology. The title is Spikelet sterility and yield of aerobic rice. The introduction. We all know that increasing pressure on water availability for irrigation led to the potential of aerobic rice development. And we also know that the upland rice culture in Indonesia is mostly under the aerobic condition. However, productivity of upland rice is much lower than flooded lowland rice. So there is importance of drought-resistant and high-yielding rice varieties to adapt the rapid change of climate. So the objective of this study is to quantify the growth and yield reduction when genotypes are grown under the aerobic condition, and also we try to identify lines that are tolerant to aerobic condition. The material first was the 17 rice varieties, and the second a set of ANOVA pot that contain of 5-liter container, 4-liter of ANOVA pot, valves, and also float in 250 milliliter jar, and also infusion set. The ANOVA pot and been designed and placed like the picture in the corner of the bottom, and the infusion set was control the water height for the aerobic and also for the flooded condition. This is the 17 rice varieties that we used in this experiment. And the experiment was a randomized complete block design with 3 replication. We used the 17 rice varieties that grown under aerobic and flood in warm temperature between 30 to 19 degrees Celsius during day or night, and also the relative humidity was arranged about 42 to 70%. The experiment was conducted from July to November 2013 in a controlled temperature glass house at Keton campus, the University of Queensland, Brisbane, Australia. Data collection and analysis. First, we collect the temperature and the relative humidity, the plant height, tiller number, the panicle number, and also take panicle weight and length, the percentage of Spikelet sterility, fertility, and diet on take panicle, also weight of 100 grain weight, the total grain weight, and also the biomass. All data tabulation on Excel, and the statistical two-way ANOVA analysis, we use the least significant difference at 5% using the GenStat. Here the picture of the plant observation. We can see here the performance of aerobic rice less better or worse compared to the flood rice growth, and also here the yield observation for the whole panicle per plant, and also for each take panicle, both for flood and also aerobic condition. And finally, the result here, we can see the first temperature and relative humidity data collection. The temperature in the control temperature glass house from July to December was set up at average maximum on 30 degrees Celsius and minimum at 19 degrees Celsius. The rice grown in the same room from seedling to harvest for both aerobic and also the flood treatments. And second, we go to the plant height data collection. Based on the two-way ANOVA, there were highly significant water treatment differences and variety differences in final plant height from sowing to harvesting date. The interaction between varieties and treatment were significant, affect the plant height at 36 days after sowing to harvest time, except at age 22 and 43 days after sowing. In general, the plant height in the aerobic treatment was lower at about 5.8 to 25.2 centimeter when compared to the flood treatment, and in the final stage, the average of aerobic treatment was about 9% smaller than the flood one. Third, the tiller number. Number of tiller was highly significant difference in water level treatment at 22 days and 29 days. However, there was no significant interaction between varieties and water level treatment except at 43 days after sowing. In average, all plants under aerobic treatment were consistently produce less tiller at about 0.12 to 1.39 tiller than that under flood treatment, except at the harvest time. Under aerobic treatment, some varieties tend to produce more tertiary tillers during the reproductive stage, and it was about 13% higher than under flood treatment. We go next to the total above ground biomass. Here we can see on average the biomass of plants under flood treatment was 13% higher than under aerobic treatment. The variety named HNN and Serpa produced the higher biomass in aerobic treatment than in flood treatment, although most of the varieties perform better in flood treatment. On panicle observation, we can see in the table, most of the plants produce more panicle under flood treatment. However, some varieties such as HMN, HSG55, Liji, Milin, PSBR-C9, and Serpa showed a higher number of panicle under aerobic treatment. In general, the highest number of panicle produced by the short varieties such as Milin in aerobic treatment and ER64 in flood treatment. In contrast, the lowest number of panicle produced by tall varieties such as VRD and UVRR under aerobic treatment and HMN under flooded treatment. Here, the Spikelet were highly significant difference on total Spikelet fertility and diet Spikelet among varieties, and significantly different for varieties by treatment interaction effect. On average, the tag panicle of plants grown under aerobic condition produced significantly less total Spikelet at about 70% less, and also less fertile Spikelet at about 6% and less dyed Spikelet at 12% than the flooded one. So the sterile Spikelet were significantly less at total 47% under flooded condition. Here the grain weight. The total grain weight was higher under flooded than the aerobic, except for the HAC55 and PSBR-C9 and YRF209, and there was significantly difference between varieties. Under flooded treatment, PRD produced the highest weight, and the lowest was produced by the BRC. However, total grain weight of KDML 105 was improved the most in the flooded condition. Under aerobic condition, the highest yield was the YRF209, which was 3% greater than the flooded, and ER64 produce the least at about 4.75 gram per plant. Weight of 100 grain was highly significant among the varieties, and grain under flood treatment also under aerobic treatment. In conclusion, based on the observation, we can say that aerobic conditions significantly increase sterility and also reduce spikelet number, spikelet yield, biomass, and height compared to the flooded one. Between those 17 genotypes, PSBR, C, and HSC55, and also LIGI were appear to be potential genotypes for aerobic rice. The future study should focus on the physiological development on each critical stage under different time and length of water stress. I'd like to address the acknowledgement to my supervisor, Professor Dr. Fukai and Dr. Jackie, who was guide me to complete this project during my master degree. That's all the presentation, and thank you.